Welcome to the AI Research Roundup. I'm Alex. Today we are looking at a paper trending on X, published on August 18th, 2025, which was just 2 days ago. The big hook is a rubric-based reinforcement learning method that extends verifiable reward learning to subjective tasks and delivers an average plus 5.2 1 percentage point improvement on open-ended benchmarks with only about 5,000 reinforcement learning samples. The paper is titled Reinforcement Learning with Rubric Anchors, and as we will see later, the implications for model training are quite significant. Beyond raw scores, the approach provides style control, reduces AI-like tone, preserves reasoning skills, and defends against reward hacking. Building on that, tweets highlight excitement about pushing reinforcement learning beyond verifiable tasks, using structured rubrics, curiosity about workflows and resources, and mild skepticism about missing construction details, with moderate engagement around dozens of likes. Alright, we are looking at a pipeline diagram that lays out the rubric-driven training loop. The left side shows data collection, where rubric design feeds tagging and selection, then produces seed data and instruction rewrite data, which a scorer function evaluates to create offline filter data. In the center, a score distribution highlights the kept band, so only mid to high quality samples flow forward. On the right, updating happens. Monotask rubric reinforcement learning generates rollouts and instruction data, which the scorer function rechecks before yielding final data. Now we are looking at a results table that compares models across several open-ended benchmarks, which is the concrete payoff of the rubric training we just discussed. The table shows baseline QN30BA3B, the Rubicon preview, and a much larger DeepSeek V3000 671B. You can see consistent gains for Rubicon preview on creative writing, writing bench, judge mark, EQ, Kali, and IFS, with a small dip on IFE. The final column reports an average, where Rubicon preview reaches about 70.5, which is roughly plus 5.2 over its base and above the larger model. Next, we are looking at a figure that illustrates a rubric-guided conversation example, which contrasts a stylized Rubicon response with the base model. You can see the prompt at the top, followed by the Rubicon thinking segment, and a polished narrative that aligns with rubric criteria, so structure and tone feel deliberate. Below that, the base model begins a more generic thinking passage, which suggests weaker stylistic control. The side note at the very top sketches the rubric fields that drive scoring. Now we are looking at a compact table that checks whether general skills and reasoning stay intact, which matters because the training targets open-ended style. You can see two model rows, with reasoning benchmarks on the left block and general benchmarks on the right block. The averages show near parity, a small drop in the reasoning mean, yet slight gains on the general mean. Notably, AIME24 ticks up, while GPQAD and LCBV5 dip a bit, so the overall balance remains stable. Now we are looking at a scatterplot titled the Seesaw Effect, which compares creative and empathy gains against instruction following performance across many tasks. You can see gray circles for the baseline, orange diamonds for creativity-focused reinforcement learning, and green squares for instruction-focused reinforcement learning, which together trace trade-off arrows per task. The vertical labels list datasets, while the horizontal axis shows performance score in percent. The right side clusters show wins, and the left outliers mark costs when pushing one side too far. We are looking at a single panel that presents the reward hacking defense rubric for question answering, which spells out how to detect opening praise and self-evaluation because those patterns can inflate scores without improving substance. The top block states the task and the two features to analyze. The middle flow lists step-by-step rules that define matches, with numbered subpoints and patterns A, B, and C. The bottom block then gives positive and negative examples so evaluators can apply the rubric consistently. Building on that defense rubric, two takeaways stand out. Rubric-anchored reinforcement learning brings reliable rewards to subjective tasks, and it does so efficiently, showing sizable creative and empathy gains without hurting core reasoning. A rubric here means weighted criteria that score multidimensional quality, with safeguards against reward hacking. That is it for the AI Research Roundup. I am Alex. Thanks for listening.